Hello and welcome to Mech Zone. Today we will be covering a topic which was left in the previous lectures, that is crashing or time cost model. So let us start with crashing or time cost model. This was the topic which was left out and today we are going to cover this up. So in the crashing or time cost model, our main aim is the minimization of the cost for the total project for the critical path method. So what we are doing here is we are actually achieving the minimization of cost of total project in case of CPM, that is critical path method. So what we are trying to achieve here is the minimization of cost. So to talk about the crashing or the time cost model, it is an extension of the critical path method that considers a compromise between the time and the cost required to complete a project. Now what we are doing here is, in order to complete the project very quickly, we are going to involve or we are going to apply large amount of labor. We will be increasing the labor input and thereby we will be decreasing the number of days which are required to complete the project. So what happens is the total cost of any project consists of the direct cost plus the indirect cost. The cost of any project is mainly made up of these two types of cost, that is the direct and the indirect cost. Okay, now if we talk about the direct cost is the cost which is directly involved in the execution of the activity. It includes the direct material, direct labor, cost of machine and cost of equipment. So these are the different types of costs which are available or which are included in the direct cost. Now we will plot a graph between the direct cost versus the activity duration, and we will see here we have the direct cost and here we have duration of activity. Okay, so this is for a straight line actually refers to the linear approximation, but actually it will be a curve. It will be definitely a curve. This point is actually representing CC, that is the crash cost. This point is representing the CN. CN means the normal cost. This is representing the time for crashing and this is representing the normal time. This angle is called as theta. So this line, as you see, it is having a negative slope. So the line is having negative slope. Okay, and this is the actual curve, whereas this is the linearly approximate curve. So this is the actual cost curve. Okay, and this is the linear approximation curve. So crashing time is defined as the minimum amount of time by which an activity can be compressed or decreased by increasing the amount of resources and hence increasing the direct cost. So crashing time is defined as the amount of time by which an activity can be compressed or decreased, and this can only be achieved by increasing the amount of resources that are being given as input. So indirectly what we are getting is we are increasing the direct cost. The slope of the line gives the amount of increase in the direct cost per unit time. So the slope of this line is giving you the amount of increase in the amount of direct cost per unit time for crashing an activity. So this is very important and you need to remember this thing, what is obtained from the slope of direct cost versus time duration. Okay, so cost time slope, if we look at cost time slope, it would be delta C upon delta T. This is nothing but equals to tan theta. This is CC minus Cn delta y upon delta x would be Tn minus Tc. So we need to remember this formula also. Okay, so what we are getting is the slope is crashing cost minus the normal cost upon normal time minus the crashing time, because the cost of crashing will be definitely high. Why it will be high? Because we are increasing the amount of resources as input. Now we talk about the indirect cost. We talk about the indirect cost, and the indirect cost is that cost which is not directly involved in the execution of the activity, but it is compulsory for safe and timely completion of the project. It is made up of two parts, that is the fixed part and the variable part. It is made up of two parts, that is the fixed and the variable part. Okay, now certain points we will discuss with respect to the numerical point of view. The first point is the crashing of the activities is always done along the critical path. We are only going to crash the activities along the critical path so as to decrease the project duration. Okay, so we will first identify the critical path and then we are going to crash the activities along the critical path only so as to achieve a decrement in the project duration, because this was our main aim. The object of crashing a network is to determine the optimum project duration corresponding to the minimum cost of the project. Now, in the critical path, we have to select the critical activity which is having the minimum cost slope. We have to select that activity which is having the minimum cost slope. Then what we will do? We will reduce the duration of the activity by 1 time unit. Reduce the duration by 1 time unit. For example, if the time is given in hours, so we will reduce it by 1 hour, or if it is given in days, then we are going to reduce it by 1 day. Now, the third step is we are going to revise the network diagram by adjusting the time and the cost of the crashed activity again, and we will again find out the critical path, project duration and the cost of project. Fourth step is if the optimum project duration is obtained, then stop, otherwise we will repeat the third step. Okay, we will repeat the third step. Okay, now we will be solving a numerical, and this numerical is a very long numerical because it has been asked in the engineering services examination. But I am explaining you only this numerical because it will cover everything that I want to explain in this particular topic. Now in this column the activities have been given, the normal time in days has been given, the normal cost has been given, crash time in days has been given, crash cost has been given, and this column we will be filling afterwards. We first look at the first, second, third, fourth and fifth columns only. Now the indirect cost per day has been given as rupees 10. Now first we have to draw the network diagram, then we will find the critical path, and we have to determine the minimum total time and the corresponding cost. Now in this question we have to apply the concepts and the logics of crashing of the activity. So these activities have been given. First we will try to draw the network diagram according to this activity precedence given. So this is the network diagram which I have drawn by looking at the column of the activity. 1 to 2, 6 days, 2 to 5, 3 days, then 1 to 3, 4 days and so on. So this network diagram is complete. Now we will find out the critical path. Now in order to find out the critical path, what we can do is, here since the network diagram is not very branched, what we can do is we can simply write down all the possible ways or all the possible combinations, that is from 1 to 2, 2 to 5, 5 to 6, 6 to 7. Ultimately the initial point is 1 and the final point is 7. So we have to move from 1 to 7. So by moving from 1 to 7, 3 types of or the 3 variable paths are possible. 1 2 5 6 7, 1 2 5 6 7, next is 1 2 4 6 7, and the next is 1 3, 4, 6, 7. So we will write all the 3 possible paths and correspondingly we will calculate the number of days which are required. So the number of days which are required for this path are the maximum number of days and hence it becomes the critical path. Now to find out the total time, we have to reduce the time taken by the activities on the critical path as it governs the duration of the project in 22 days. So here the critical path is having 22 days and this is actually going to govern the project. So we see that 1, 2, 4, 6, 7. So 1, 2, 4, 1, 2, 2, 4 and 6, 7 are the critical activities. So what we will do is we are going to look only at those activities. Now for 1, 2, normal time is 6, crashing time is 4. So we can crash this activity maximum by 2 days. For 2 to 4, the crashing time is 3 and the normal time is 5. So it can be crashed maximum by 2 days. Now what was the activity? 4 to 6. In the 4 to 6, normal time is 8 days and the crashing time is 4. So we can crash it by maximum 4 days. Next is 6 to 7. Normal is 3. Crashing is 2. So we can crash it only by 1 day. Now we have to identify the least cost of crashing and then we will go for the crashing of the activity. On crashing one of the critical path by 1 day, we will have 2 critical paths for 21 days. For example, if we are crashing any of the activities, say 1 to 2, 2 to 4, 4 to 6 or 6 to 7 by 1 day, then the entire project duration will be reduced by 1 day and it will come out to 21 days. Now 21 days for this path also and 21 days for this path also. So both will become the critical path. So the normal cost of the project can be simply evaluated by adding this column 60 plus 60 plus 50 plus 45 plus 90 plus 80 plus 40 plus 45. It is coming out to be 470. So this is I have written from the table. Now total indirect cost of the project. Since we have been given number of days as 22 days and the indirect cost was given as rupees 10 per day. So the total indirect cost becomes rupees 220. So the total cost becomes 470 plus 220, that is 690. Now we will go for the crashing of the activities, but first we will identify in the critical path the activity which is having the lowest cost of the crashing per day. Now if we look in the table, the activity 1 to 2 is having the minimum cost of crashing per day. We have to look only for those activities which are included in the critical path. So we have 1 to 2, 2 to 4, 4 to 6 and 6 to 7. So we will crash 1 to 2 by 1 day so that the project duration becomes 21 days. Okay. So the cost per day is given as 20. How we are obtaining 20? We are obtaining 20 as 100 minus 60 upon 6 minus 4. So we are obtaining 20 and 20 is the least cost corresponding to the critical path activities. Okay. So how is 70 obtained? 200 minus 60 upon 4 minus 2 will give you 70. So this table will be calculated as follows. Now we will decrease 1 day in the activity from 1 to 2 and what we will obtain? We will obtain 21 days. So crashing cost for 1 to 2 is 20 rupees which has already been given. Now what will be the effect of crashing? Since the activity 1 to 2 is involved in this path and it is not included in this path. So these two paths will be reduced by 1 day and hence 16 becomes 15 days and 22 becomes 21 days. Now we have two critical paths 1, 2, 4, 6, 7, 21 days and 1, 3, 4, 6, 7 also 21 days. Now since both are critical paths. Now because of the two critical paths we will crash the activities in such a manner so that the project duration is reduced. This was our aim. If we crash 1 to 2 activity, then for the second critical path the time will be reduced by it and will have no effect on the third critical path. So this is very but obvious that can be seen here कि अगर हम लोग 1 to 2 वाली जो एक्टिविटी है उसको एक दिन से रिड्यूस कर दें, then for the second critical path the time will be reduced by it, will have no effect on the third critical path. So for the critical path, what we are going to do, we are going to make combinations, and for those combinations we will be crashing those combinations one by one in the order of their increasing cost. Now in the critical path we had 1, 2, 4, 6, 7. So, and we also had 1, 3, 4, 6, 7. So what we are going to do is we are going to make possible combinations for crashing 1 to 2, 1 to 3, 1 say 2, 3 say 4, 2 say 4, 1 say 3, 2 say 4, 3 say 4, 4 to 6, 6 to 7. Now these are the possible combinations which can be made for crashing. And we see that for these two critical paths, now we are considering these two critical paths, and we see that 4 to 6 is the common activity which can be encountered in both these critical paths. So 4 to 6 and 6 to 7 is the common critical activity. Now we find out the cost corresponding to 1 to 2 and 1 to 3. So for 1 to 2 it's 20 and 1 to 3 is 70, so total becomes 90. So I have written 90 here, and correspondingly we will obtain 75, 120, 105, and for 4 to 6 we are obtaining 55, and 6 to 7 we are obtaining 35. Now since this is having the lowest cost of crashing per day, we will crash 6 to 7 activity only by one day. Why we will crash it only by one day? Because we are moving from one only. एक एक करके हम लोग एक एक दिन या एक एक यूनिट टाइम से क्रैश करेंगे. So normal time is given as 3 days and the crash time is given as 2 days. क्यों? तो हम लोग that is why we can crash it only by one day. So crashing activity 6 to 7 by one day. So cost of crashing we have already calculated, and it is 35 for the activity 6 to 7. So here becomes 35. New project duration. Now since 21 will be reduced by one day, so the new project duration becomes 20 days. Now 6 to 7 is included in all these things. So 15 would be reduced to 14, 21 would be reduced to 20, and this will also be reduced to 20. Now we go for the third crashing. Now for the third crashing, now since activity 6 to 7 has been crashed completely, we cannot crash it further. Now for the third crashing, we move on to the combinations of 4 to 6, since it is having the next least cost, that is 55. Rest all the costs are greater than 55. Now we see that we can crash activity 4 to 6 by 4 days. Why 4 days? If we look at the table, so crashing time has been given as 4 days and the normal time has been given as 8 days. So difference is 4, and therefore we can crash it by 4 days. Now if we crash it by 4 days, the crash cost that was involved is 220 rupees, corresponding to 4 to 6. Okay. Now project duration for this is 16 days. Now after that we go for the fourth crashing, and in the fourth crashing we are going to crash the combination of 1 to 2 and 3 to 4. However, this type of question is very lengthy to answer, but in GATE only a certain portion will be asked. For example, in the table that we have seen, 10 values are given, but in GATE only 3 or 4 values will be given, and the question will be very simple. Okay, so therefore we go for the crashing of combination 1 to 2 and 3 to 4. Common time available for both is 1 day. Why 1 day? If we look at the activities 1 to 2 and 3 to 4, 1 to 2 we have the crashing time as 2, that is 6 minus 4, and 3 to 4 the crashing time available is 2 days, that is 6 minus 4. So now the project duration becomes 15 days. So for the first path, when we will reduce it by 1 day, it becomes 13 days, and these two critical paths we will obtain 15 days. Now for the combination 1 to 2 and 1 to 3, 1 2 has already been crashed, so we will not crash it further. It has been completely exhausted. Now the next lowest cost corresponding to we will find for 2 to 4 and 3 to 4, which is 105 rupees. So common crashing time for the combination is equals to 1 day. We can see it from the table, and crashing cost is 105. And after reducing it by 1 day, what we will obtain? 2 to 4 and 3 to 4. 2 to 4 is in this and 3 to 4 is in this. So we are going to reduce only 1 day from these two activities, that is 14 and 14. Now we go for the crashing of the next combination, that is 2 to 4, 1 to 3 pair of activity. 2 to 4 can be crashed by 1 day and 1 to 3 can be crashed by 2 days. Common crashing time becomes 1 day. So we will crash it by 1 day. So 2 to 4 and 1 to 3 both are being crashed by 1 day, and the crashing cost which will be obtained from the table that we have drawn is 120 days. And if we reduce it by 1 day, then the next new project duration become 13 days. Here 2 and 4 and 1 and 3 both are reduced by 1 day. So since 2 and 4 and 1 and 3 are not included in this, so it has no effect. Therefore these two will be reduced by 1 day and it becomes 13 days. Now all the above critical paths we find for those activities which can be crashed. Since we have almost crashed all the activities, none of the activities can be crashed further. 1 to 2, 2 to 4, 4 to 6, 6 to 7, 1 to 3, 3 to 4, 4 to 6, 6 to 7. All the activities have been crashed, so we cannot crash it further. So what we find is the minimum total is 13 days. And the cost of the project would be the normal cost plus the crashing cost plus the indirect cost. So the normal cost was obtained from the table. I have written NC as 470. Crashing cost, what we will do is we will obtain it from the stepwise, that is 20 into 35 plus 220 plus 75 plus 105 plus 120. This was the crashing cost corresponding to all the activities. And indirect cost was 13 days and cost rupees 10 per day. So 10 into 13. So the total cost project becomes 1175. So this was all about the crashing of the activities or crashing problem that we have discussed right now. What we have to mainly do is we have to mainly identify the critical path, and we will crash the activities only along the critical path such that the number of days are reduced and indirect cost or direct cost generally is increased. So with this we come to the end of this lecture. We hope that you are enjoying our lectures. Please give us your valuable feedbacks and also share your problems with us on our channel, or you can share it on the Facebook page also. And do tell others about our channel so that they may also get benefited, because all the study material and all video lectures, and that too quality video lectures, are available on our channel absolutely for free. So thank you for today.